Hello everybody, I'm Vitek from Verso Studio and I would like to welcome you to another Blender tutorial. In this video I will show you how to recreate the animation that you are watching right now. All that we will need is just Blender, black and white texture of the continents and Animation Notes add-on version 2.0.4 or later. You should find the links to everything in the description of this video. Down there you will also find timestamps of different parts of this tutorial, like modeling, animation and rendering. Okay, if you have everything prepared, let's jump right into the Blender. Let's start with adding an icosphere that has a nice even topology and crank up the subdivisions to 5. So we have enough geometry to work with. Just don't forget to set the shading to smooth and name the object reasonably. Well, that's pretty much it. We are finished with modeling. The rest of the work will be done by modifiers. We need to hide specific parts of the mesh, and the best candidate for that is of course the mask modifier that can hide vertices based on the vertex group. So far we don't have any vertex groups in our mesh, so the sphere disappeared entirely. Let's create one. Just go to the mesh properties and hit the big plus in the vertex group tab. Now we need to say which vertices are part of the continents and should be in this group and which are not. For that we will use another modifier named vertex weight edit. Put it above the mask modifier, hide the mask temporarily and switch to the weight paint mode, so we will see what is actually happening with the group. You can see that everything is blue for now. That means that nothing is in the group or the weight of it is 0, which basically means the same thing. Otherwise it would be red. Now let's tell our modifier which group it should actually edit and check the group add, so we will actually put the vertices to the group, but only those that have their weight above 0.01. Which means that no vertices are added right now because all the weights are 0. Change the fall of type from linear to custom curve so we can play with it. The default line doesn't do anything at all. If the source weight value is 0, the final value is also 0, 1 is 1, 0.5 is 0.5. But if we move or add some points to it, we can change the resulting value. For example, if we put the left point all the way up, no matter what the input weight was, the result will be always 1. You can see that all vertices are red now, and that means we effectively added them to the group. The best thing about this modifier is that we can put texture mask here and tell the modifier when to work and when not. And this is the moment for our black and white texture of the continents. Well, before we will use it, we need to map it somehow to the sphere, and the best way will probably be to use UV coordinates. Let's split the view so we can have a UV image editor and see what we are doing. Open the texture there and switch to the edit mode. With everything selected, just hit U and choose sphere projection. The default settings are aligned to the view, and that's pretty much always wrong. Just set the direction to align to object. Well, that's all for the unwrapping. We can get rid of the image editor and go back to the weight paint mode. Now if we use the texture mask, set the coordinates to the UV and pick the right image. You should see that continents are now red and water is blue. And that's exactly what we wanted. Go back to the modifier panel, activate the mask modifier again and give it a group. Voila, the water successfully disappeared. Back in the object mode, you can see that the resolution is not nearly enough for our needs. Easy solution, the well-known subsurf modifier. Don't forget to put it above everything else. Remember that the order of modifiers is very important. I think that 4 levels will be enough for the render and just 3 for the viewport, so it will remain responsive. If you don't like the jagged lines, just put another subsurf after the mask. The default settings should be more than enough. It still lacks some thickness, so let's finish it with a solidify modifier. The shading is kind of weird right now. I still want a smooth surface, but the edges of the continents should be actually sharp. I can use edge split modifier of course, but I think that it would generate just too much unnecessary geometry. Let's rather use Auto Smooth in Mesh Properties and set the angle to almost 90 degrees. We are pretty much done right now. Just create another icosphere for the oceans, set the size to 0.9, shading smooth, and name it properly. And just like that, we finished the modeling. In this part, we will use the Animation Nodes add-on to generate the arcs from simple Bezier curves. Go to the second layer and create one. It won't be visible in the render like that, so we need to give it some thickness. So set the bevel factor to something like 5. The exact value is not that important right now. We will change it later with the animation nodes based on the length of the arc. As you can see, the geometry doesn't go all the way around, and that's because the fill property is set to half and we need to change it to full. Also, the resolution could be a bit higher. Every arc will consist just from 3 points, the beginning and the end, that will connect some random points on the surface of the arc, and middle point, which we will use for controlling the height of the arc. We can go back to the first layer and define all the random points that we will need. The easiest way is probably to use particle system, so let's add one. In the modifier panel, get rid of few subsurf levels to speed up the performance and put the particle system above the solidify, so the particles are not emitted from the bottom of the continents. And back to the particle settings. We definitely don't need thousands of them, so change the emission number to something a lot below 100. I will try 64. Also, we don't need any animations or physics simulations, we just want the points to be there. So set the start and end to 0, lifetime to something arbitrarily high like 10,000, and don't forget to activate use modifier stack. Normal velocity 0, and finally no physics. That's pretty much it. If you want to see where those points are, increase the draw size in the display panel, and if you don't like the placing, play with the seed value. Okay, now we have the curve and points, so we can go to the node editor and do the rest. When you create new node tree, usually the first thing you want to do is change how often it's triggered. The always option is unnecessary waste of resources. The nodes should refresh only when something is changed. Rename the node tree to something reasonable and start adding all the essential nodes. First, we need to add all those particles, so add particle system from object and particles data. Connect them and pick the continents. Now we have all the points to our desire. But for the creation of the arc, the individual points are not enough. We need pairs of them, and we will find them two different ways. The first method will use mesh operator find close points with amount of 2, and that will just find all the pairs that are close to each other. It will give us the edges, and that's not exactly what we want, so let's put there mesh operator edge info, and now we have everything we need: start points and even the middle points and length. We can create the arcs just from this, but I would like to have few completely random connections around the air. So for the second method, we will create our own node that will do exactly that. Create new node tree, name it for example find random pairs, and turn off the execution completely. Now add subprograms loop, give it again a reasonable name, and create a new parameter vector list, so we can work with all the locations at once. For the outputs, we need 3 vector lists for starts, ends and centers, and 1 float list for the lengths. You can change the naming of the outputs in their advanced node settings. Okay, let's pick 2 random points from the list with list getRandomElements. Put the index to the seed value so it will pick different pair every time. Connect the list and set the amount to 2, of course. Getting the start and end now is super easy. Just pick the first and second element from the new list, which contains just the 2 points. Center should be an average of those 2 points, so use vector mix node with factor of exactly 0.5. And finally, the length is just a distance between the start and end. The vector distance is the perfect node for that job. We are now done with our random pair finding node 3. Let's go back to the generator and use it. You should find it in the subprograms, connect the locations and set the iterations to your heart desire. The number of iterations is exactly how many pairs you will get. I like to have things connected and don't write any concrete numbers, so I will set it to 20% of all location. We cannot work with two separate lists at once. We need to combine them. Just add the list combine vector and list combine float. It's also nice to keep the naming recognizable. Now we need to create all those curves that we will be working with. Just add an object instancer, select the curve and check the deep copy, so we can edit them individually. Connect the starts to the instances, so we have perfect amount of them. We can finally edit them according to our points, but because it's a bunch of them, let's do it in the loop in the new node 3. So new 3, rename, turn off the execution and add subprogram loop. We need 5 iterators, object list for the curves, 3 vector lists for the starts, ends and centers, and finally float list for the lengths. Let's quickly switch back to the generator and put our new loop there, so we will actually see the result in the viewport. Back in the arcs node 3, let's finish our work. Sometimes it's the best to start from the finish, so put the spline object output here first. Connect the curves and activate the spline and bevel depth. The bevel depth is definitely the easier one, so we can start with it. It should be directly dependent on the length, with just a math node that will scale the overall value along the way. Also, it's nice to clamp that value so it doesn't go to some weird extremes. Now for the spline. Fortunately, in the animation nodes there is a handy node that can create splines directly from points, and that's exactly what we want. We just need to feed our points to it. But first we have to convert our 3 separate points to one nice list. We should already see our curves in the 3D view, but unfortunately they are straight lines going through the air. We need to push the middle points further away from the center of the earth. Probably the best control that we can have is to set them directly some new length. Add vector math to them and set the mode to normalize. Now when we set the length to more than 1, you can see they are finally above the surface. It would be nice to control the height again with the length of the arcs, but putting it there directly definitely doesn't work. We need to remap the range of those values. The radius of the arcs is exactly 1, so the distance can be from 0 to 2. And we want our height to be from 1, which is directly on the surface, to something little higher. I will go to 1.3. You can even try to play with the interpolation option. Well, everything looks like it works, but instead of nice curves, we have straight lines. The solution is really simple, just use spline smooth Bezier. Play with the smoothness value until you get the desired result. Only one thing that could be better is the resolution of the spline, so change the preview resolution in the curve object output, and that's all for this part. Let's move on to the animation. I will use animation nodes for the movement as well, but I don't want everything to be refreshed on every single frame, so go to the generator node 3, turn off the execution and create a new tree. As always, rename it and change the execution only to be triggered when something changes. We need to somehow address all the arcs from this new node 3, so switch quickly to the 3D view, select one of them and use Shift G and choose type to select also the rest of them, and hit Ctrl G which will add them to the new group. Back in the node editor, we can address them now with the object from group node, and because it's bunch of them, we will use another loop for the editing. Choose appropriate name and add an object list iterator. I will also add the list to the node tree so I can see the result of what I am doing. The whole animation will be done just by editing the start and end values of the curves bevel. Both these values can be found in the spline object output node. Connect the arcs and you can play with the values. To make this animated, we want to change the values from 0 to 1 based on the current frame number. The frame number is just a time info node. And to control the animation, we will use simple map range. The output min and max will be always 0 and 1. That's the range of values we want to achieve. And the input min and max will be the start and end of our animation. To make it a little bit interesting, I want to start of the animation to be different for every arc. So I will use some random number from 15 to 90. In 30 FPS, it's almost 3 whole seconds of variation. Don't forget to put the index to the seed value, or it will be calculated just once. The movement should take around 1 second, so the end will be 30 frames more than the start. So add 30 to the random number and plug it to the input max. When you now play the animation, you should see that it works. If the playback is too slow, just lower the subsurf levels and get rid of the particle system. For the bevel start, we will do the exact same thing, just 30 frames later. So copy the map range, plug the frame number, and the input min will be the last value plus 30 and the input max plus another 30. That should be all for the arcs. Now just rotate the camera around. We don't need the animation nodes for that, so switch to the 3D view, add the camera, place it wherever you want and parent it to empty in the middle of the scene. Now when we rotate the empty, the camera will follow. Set the start and end of the animation. I think about 180 frames should be enough, and put a keyframe on the empty's rotation. Jump to the last frame, rotate the empty 360 degrees around the Z-axis and keyframe it again. When you now play the animation, you see that the rotation speed is gradually changing. Maybe it's the behavior you want, but I don't. So I will go to the graph editor and change the interpolation to linear. That should be all for the animation, so let's create some shaders and render the result. Let's start with the lighting. If the rendering preview can't go past the first sample, just temporarily turn off the animation nodes. And putting some HDR environment map to the world should be more than enough. Some HDR map will put too much color to the image and we are in space, so crank the saturation down. Now select the ocean and make a new material. Change the diffuse shader to principled and set it to metallic. Pick some nice color and we are almost there. Now I would like to visually separate the polygons. Good trick for it is to use parametric input from geometry node and use it as bump map. Just lower the strength a bit. If we want even more separation, we can use a wireframe input to influence the color. I want pretty much the same shader for the continents, but their topology is messed up with the modifiers, so we unfortunately can't use the wireframe nor the parametric. Well, we can kind of cheat and use UV coordinates. Select the continents, go to the edit mode, create a new UV map, make sure everything is selected and hit U and choose reset. In the UV image editor, we can see that all the triangles are unwrapped the same way. Create a new material on the continents and put the UV map there. Let's see what we can do with it. We can separate the coordinates and find the edges of the triangle. The bottom one is everything that has really low Y values. The right vertical edge is everything that has x values almost 1, and the diagonal is where the x and y are almost the same. In other words, the difference between x and y is very small. If we combine all of that together, we have our own wireframe. It's always nice to have control over multiple values from just one place, so add a value input here. Now we can replicate the shader of the ocean just with darker colors. After that, we can make shader for the curves. Don't forget to go back to the object mode, of course. Switch to some frame where the curves are visible. If you don't see them, you will need to activate the animation nodes again. Select one of them, create a new material for it, and redistribute the material to all of them. They are in the same group. We can use it for the selection, so hit Shift G, pick group, then hit Ctrl L and pick materials. With this material, you can do pretty much whatever you want. I found that nice result gives mixing the emission shader for volume and refraction for surface. And again, to make it interesting, try put random color to each one of them. Simply add input object info and run the random value through the color ramp. Here you can put all the colors that your heart desire. Well, and we are done. Just don't forget to activate the animation nodes again. Just set the render according to your PC and start the render. I hope that you've learned something helpful for your projects. Let me know your opinions and suggestions. I thank you very much for watching, and till the next time, happy blending!